Okay, this video is for those students who are absent on January 10th and 11th, and I'll probably put another one together for those that are absent on the 12th and the 13th, and any others later on. So today in class, and that'd be the 10th or the 11th, we went over the Lewis structures that they assigned, dealing with ions, organic compounds, and acids. We then started an activity. It's located in Drive that's titled the VSEPR Theory Activity. I believe that's what it is. In that document, we are using those Lewis structures and compounds that we've already done, and we are listing the compound, we're drawing the Lewis structure again, and we're doing an activity to, and we're identifying this VSEPR and steric number. These things we've already done. We're then going through and identifying the group geometry and molecular geometry and bond angle. This is being done using a website called PhET, and you can access that on your iPad through the link that is in the document. Unfortunately, you do not have access at home to model kits that we are using, and we're building these models so that we have a better idea of what they look like three-dimensionally and being able to hold them. Now, you can do that, it simulates it fairly well in that PhET activity, but you don't have the tactile response of being able to hold the molecule and see what it looks like in an actual three-dimensional environment. I will have another video up associated with that activity online. So you can view that and see what you need to do and how the program works and what you need to do to be able to fill this out. The one thing that we went over in class that I want to go over with you right now is the addition of arrows on the Lewis structures to represent the polarity of the bonds within the molecules. I'm going to give you two examples. They're really simple, quick. So in our water molecule, we have this. And again, I'm not overly concerned about how you draw, where, are they in a straight line or whatever. I'm going to draw them to represent them as much as they can be in three dimensions. But hydrogen, if you look up its electronegativity, in an electronegativity from your textbook, has an electronegativity of 2.2. And the oxygen's electronegativity is 3.5. Now we know based on lecture, when we talked about chemical bonding, that the sharing of electrons between a hydrogen and an oxygen is going to be unequal. Now that leads to some properties that we're going to talk about in later classes. But what I want you to do is on the Lewis structures that you redraw for the document that's for the VSEPR Theory Activity, I want you to put an arrow on the bonds representing the direction that the electrons would be shifting towards. So in this case, they're going to be shifting towards the oxygen. The oxygen is going to be, since it has a greater attraction, the electrons will be pulled closer to it. Another example would be sulfur trioxide. And in this case, what you'd want to do is, I know oxygen's 3.5. I can't remember what the electronegativity for sulfur is. I think it might be about 2.8. You'd have to look it up. But what you would do in every one of these oxygens here is you would point the arrow away from the sulfur towards it. Now on a double bond, I don't really care how you do it. We're just representing what way the electrons are going to shift, and we would simply draw it. I would do it like that. So it's just for us to be able to use later on, and just showing how these electronegativity values are going to affect how the sharing of those electrons occurs. Hope to see you soon. If you're sick, get better. If you're not, hope you stay not. And talk to you later.